Hey class, Mr. Prosky here. Hope you're having a good day so far. We're continuing Chapter 5, which is quadratic equations, quadratic functions, which is parabola, stuff like that. And this is 5.2 day 1, and it's factoring methods. And this is a very hard section. It's going to be a long video, so just keep that in mind. Factoring is important because we talk about, like, for example, like factored form. To solve a quadratic equation, the solutions are where it crosses the x-axis, right? So if we have a parabola here, the solutions are right here and right here. That's how you solve a quadratic function or quadratic equation, okay? So factoring is going to be very important to help us do that. And so we have a tool that's going to go back to Algebra 1, which is our factor flowchart. It says factoring sheet here. I'm going to attach it to the lesson, hopefully, and then you guys are able to see that, because it is very important. Let's go ahead and take a look at what it looks like here. Oops, got to go back down to my tools. So I'm going to attach both one that has all the instructions in the middle here like this, or ones that are just kind of blank, and just kind of the other one would be just the updated that just has the steps without the actual words explaining it and stuff. But let me talk you through how this kind of works here, okay? So the factor flowchart, you always start with looking for a GCF, which stands for greatest common factor. All right, a greatest common factor is the biggest number that goes into all the terms and the smallest exponent that goes into all the terms. So for example, if we had 2x squared plus 4x, the biggest number that goes into 2 and 4 is 2. The smallest exponent between x squared and x is x. Then we divide both of these by 2x to get what's left over, basically. So factoring is division. So when we divide 2x squared divided by 2x, we're going to get x. And 4x divided by 2x is going to be 2. So this would be the factored form. It would be 2x times x plus 2. If you were to redistribute this, you get back to the original thing. But we're not really doing distribution. We're doing the opposite. And factoring is the opposite of distribution, basically. Okay? Do this so that I can get back to my original document. Okay, after you find a GCF, if there is one, you want to check the number of terms, okay? If there are 2 terms, you might do difference of squares. And difference of squares depends on if you have perfect squares for your terms here. So 4x squared is a perfect square because it's 2x times 2x. 81 is a perfect square because it's 9 times 9, right? So perfect squares are numbers that multiply by themselves, right? So if you have, for example, 16 is a perfect square because that's 4 times 4. 49 is a perfect square because that's 7 times 7. Those are examples of perfect squares, okay? And those are important for a difference of squares and also perfect square trinomials. And so when you see something like a difference of squares, which is 2 perfect squares with a minus sign between them, that's going to factor to the square root plus the second square root and the square root minus the second square root. That's just how it's going to factor. So if we were to redistribute this 2x plus 9 times 2x minus 9, we go like this, and we go like this, we're going to get 4x squared minus 81. It's kind of a shortcut. Instead of actually, like, it's kind of working the opposite direction. Instead of distributing, we're unfoiling, or we're factoring, which is the opposite of foiling, okay? So the shortcut for 4x squared minus 81 is going to be 2x plus 9 to 2x minus 9. If you have 3 terms, you have a few different options here. The super cool method we probably won't talk about so much in this class because it's I may talk about it briefly, but it's not as useful as a different one we're going to talk about. A perfect square trinomial is similar to a difference of squares. You can see the first term and the last term are both perfect squares again, but the middle term is going to be double the square roots of the first and the last term. So square root of 9x squared is 3x. Square root of 16 is 4. 3x times 4 is 12x. What's double 12x? Is that 24x? It is. So that's kind of another shortcut. So when you see basically what you're looking for is perfect squares in the first and last terms, because when you get that, it's going to factor without having to do the factoring method. Okay. Let's go ahead and get rid of all this. Okay, and then general factoring and trial and error we'll talk about a little bit more closely when we get into the actual problems here. So let's go ahead and get into this now. So I'm gonna be going back to this factor flow chart pretty consistently. So just be prepared for that. Okay, so Use your factoring sheet and follow the steps. You're always going to start by looking for a GCF, like we talked about, a greatest common factor. So just so we don't remember what we were talking about there, if we have 2x plus 6, the biggest number that goes into 2 and 6 is 2. The smallest exponent is no exponent. This one doesn't have an exponent, doesn't have an x, right? So the GCF is going to be 2. We're going to divide both of these by 2, which is going to give us 2 times 2x divided by 2 is x, 6 divided by 2 is 3, and this would be factored using a GCF. We have 2 times x plus 3. All right? A GCF says any factors that all terms have in common. And what I wanted you to write down here, too, that's kind of important, the GCF is the largest number and smallest exponent. And box that. That is very important. That's how you find a GCF. It's the biggest number that goes into all the terms and the smallest exponent that goes into all the terms. Okay? All right, moving on. A difference of squares must be a subtraction of 2, like we talked about, perfect squares. And difference means subtraction. Oops, squares. Difference of 2 perfect squares. Let me write that a little bit better. Difference of 2 perfect squares is a subtraction of 2 perfect squares. All right, so we have some examples here. Let's go ahead and do these examples. Okay, so we have 24x to the third minus 30x to the fourth. First thing we look for on our factor flow chart, like we talked about, and hopefully you'll have access to this during the video instead of me going back and forth to it, is to look for a GCF. Okay, we're looking for a number or exponent that goes into all the terms. Do we have a number or exponent that goes into all these terms? Well, 24 and 30 are both even numbers, so at least 2 goes into both these numbers, but also the biggest number that goes into these is actually 6. So we're going to divide these both by 6 at least, maybe something else too. And then what's the smallest exponent that we can pull out of here? X to the third or x to the fourth? Which one's smaller? We can pull out an x to the third. Okay, so when you factor, you divide everything by the GCF. So our final answer is going to be 6. Well, not final answer, we're going to check. 6x to the third. GCF. We did have a GCF. 6x to the third. Now we got to divide both of these by 6x to the third. What's 24 divided by 6? That is 4. And then x to the thirds are going to cancel out. And then what is 30 divided by 6? Negative 5, and then x to the fourth divided by x to the third. When you divide exponents, you subtract them. So 3 minus 3 is 0, or just, there's no x. Excuse me, 4 minus 3 is 1, so we get just negative 5x. Okay, we did have a GCF. We also want to check inside the parentheses to see if those are also that's also something that we can factor. So we have 4 minus 5x. Are either of those perfect squares? Well, 4 is a perfect square because that's 2 times 2, but is negative 5x or is 5x a perfect square? What's something that you can multiply by itself to get 5x? Well, you can't, right? It's not like 16 or 9 or anything. So this is actually where we're going to stop. So we're going to check for, there's 2 terms. Okay, I'm not going to go back and forth between the factor flow chart and not. You should have that open while you're watching this video. There's 2 terms, difference of squares, and the answer is no. I'm going to move this over, actually. Okay, I'm going through the steps every time here. Let's actually number these. And that means we're done. If this is our final answer, we had 6x to the third times 4 minus 5x. That is factored as far as we can go. Okay, so we're going to go through the steps every time here to help us with this, okay? So number 2, we have 121 minus 25x squared. So first things first, is there a number that goes into 121 and 25x squared? No, and this one doesn't have an x, we can't plot an x either. So there's no GCF. So we're going to go like this. We're going to go, number 1 is GCF, and no. Second step is how many terms? Second step is we have 2 terms. Terms are everything divided by a subtraction or addition symbol. So we have 1 term here, 1 term here. So we have 2 terms. Now, third step is to check on the factor flowchart if it's if it's a difference of squares. So is it a difference of squares? Well, for it to be a difference of squares, we need perfect squares for the first term and the last term. Is 121 a perfect square? What times what is 121? That's the same number. This is 11 squared, isn't it? What about 25x squared? What can we multiply by? What times itself is 25? Well, we got 5, and then x times x is going to be 25x squared, right? So the shortcut, if you go to your factor flowchart, once you figure out these little terms right here, all you have to do is follow the pattern, which is going to be the first term plus the second term, and the first term minus the second term. And that's it. I'm going to put yes over here. And we're done. So this is factored. Okay, and factored means undoing FOIL, trying to get stuff as simple as possible. All right, number 3. We have 8x squared minus 72. Is there a GCF? First thing we always look for on our factor flowchart is GCF. What do you guys think? They're both even, so at least the number 2 goes into both of these. Is there a bigger number that goes into both of these? And also, another thing I'm going to attach, if this has been a struggle for you, hopefully this will be helpful, but if we go to our tools, we go to our factors and multiples table. So we're looking for 72 and 8. So here's 8. 8 is right here. So these are numbers that go into 8, right? And then we have numbers that go into 72, the factors. 72 is right here. So these are all numbers that go into 72. So what's the biggest number that goes into both of these? Well, you can see 8 goes into both of these. So that's going to be our GCF. So we're going to pull out 8s. Okay, so our GCF is 8. This one does not have an x, so we can't pull out an x. So our GCF is 8. So now we're going to divide both of these by 8. That's how we do that to factor. So we have 8 times x squared. 8s are going to cancel, minus 9. All right, second step. We're done with the 8's going to kind of come along for the ride, but we're going to worry about what's inside the parentheses now. So in the parentheses, how many terms do we have here? We have 2. So if only pattern for 2 terms is difference of squares, right? Is it a difference of squares? Well, what's x squared? Is that a perfect square? Yeah, that's x squared. What about 9? That's 3 squared, right? Okay, so that means this is yes, which means it's going to factor. The pattern is going to be, it's an automatic thing. It's not really anything math to do. It's just kind of a pattern. It's going to be the first term plus the second term, the square roots, and the first term minus the second term, square roots. And this is factored as far as we can go. Okay, so we're going to do these steps every single time on the left, or on like these steps over here, every single time to get you in the habit of doing these problems very methodically, because they can be pretty overwhelming otherwise. All right, moving on, smiley face method. Okay, so this is when you have something like ax squared plus bx plus c, when a equals 1 or when a does not equal 1. So there's a lot of things to talk about here for this problems, okay? So we have m squared plus 15m plus 50. So what we're trying to find here is we're trying to find something that's going to go in these parentheses here, something like m plus 2 and m plus 10, something like that. We're going to try to unfoil is what we're trying to do, okay? There's a couple things we need to talk about here, okay? Let's go through our steps first of all, though. Step 1 is always GCF. Do we have a GCF for these problems here? Well, this is a 1m squared, so no numbers. This one doesn't have an m over here, so there's no GCF. Second step is to check for terms. And we have 3. Step 3 is to check for a perfect square trinomial. And perfect square trinomial is going to have a perfect square here and a perfect square here, and the middle is going to be double the AB. The two square roots are going to be multiplied in the middle here. Well, is 50 a perfect square or no? This is not a perfect square trinomial. That is. This 50 is not a perfect square. If it were 64, that would be. So then the next thing we need to do is we need to do smiley face. Okay, so now we're going to go ahead and do this. So what we need factors of the first term and factors of the last term, things that multiply to the first term and last term that are going to give us a middle term of 15m when we add them, okay? So what multiplies to m squared? What are the only ways we can multiply m squared to get m squared? Well, we can only multiply m by m. Factors are what multiply to that thing, okay? So it's going to be m times n, so automatically we're going to have in our parentheses here at the very beginning is going to be m and m. We know those are going to have to go there because that's the only factors of m squared. Okay, now we need to check the signs. We could have a plus and a minus here. We could have a plus and a plus, a minus and a minus, but we're not sure yet. So let's take a look at this here. So if these are both positive, the only way to get two positives and to end up with this negative, this positive 50 and a positive is if you have a positive times a positive, okay? We'll talk more about other different variations here, but the only way to get positive 50 when you multiply and positive 15m is if they're both positive. So let's do some factors of 50 now. What multiplies to 50? Well, we have 1 times 50. We have 2 times 25. You can use your factor and multiple chart if you need to do this. And I think that's it. Oh, and 5 and 10. Those are the factors of 50. So if you see, if we put like 10 and 5 here, which might actually be the right answer, but we'll come back to that in a second here. If we had a negative here, if we had positive 10 and negative 5, that would give us a negative 50 right here, okay? So if these are both positive, here, the only way to get two positives is if everything is positive. So let's try some. We're not going to try the right answer first. We're going to try a wrong answer first. We're going to try, let's do 2 and 25. So we're going to plug in 2 and 25. We're plugging in these factors over here. So plus 25. Okay, the way the smiley face method works is we're going to do this. We're going to go to the middle terms and the outside terms. So what is 2 times m going to be? Well, that is 2m, right? What is m times 25? That is 25m. Make sure you write in pencil here with this. We're going to have to do some erasing or write some other stuff here, okay? Okay, so we have this. What is 2 plus 25? Is that going to be 15 in the middle here when we add these together or no? That's going to be 27m. So this is not the right combination. If you were to FOIL this, you would get m squared, m times m, plus 25m, plus 2m, plus 50, right? And that would give you m squared plus 27m plus 50. So you see what we're doing here? We're trying to figure out what's going to make the FOIL work. We have 15m here, but we got 27m when we plugged in the wrong numbers into the wrong spot. Okay? So let's go back. We're going to have to try different, be strategic about our guessing. This is kind of a guess and check method. So let's try, instead of 2 and 25, we need to add up to 15. Let's try, we can do 5 and 10. We can get 15 from 5 and 10. So let's give that a try. So 5 times m is 5m. M times 10 is 10m. And then when 5m plus 10m equals 15m, this is probably the right answer because we're going to get m squared plus 10m plus 5m plus 50, which equals m squared plus 15m plus 50. So this is our final answer is not like guessing this stuff. Our final answer is the factored form, which is going to equal this. This is our final answer, what I'm boxing right here. Actually, I'll rewrite it over here. M plus 5, m plus 10. Okay, so that is the smiley face method. So now we did smiley face and we're done. Okay, it's smiley face because it makes it kind of a smile in the middle there with the loops. Okay, let's do number 2. Moving on. We have x squared minus 6x minus 27. Okay, so first things first. What's the first thing we check when we're doing any kind of factoring? Is there a GCF, right? So is there a GCF? Is there a number that goes into x squared? Well, this is a 1x squared, so there's no numbers that go into all those that's going to work. This one doesn't have an x, there's no GCF. Okay, step 2 is to check for how many terms. In terms, in this case, we have 1, 2, 3 terms, right? It's however many things are separated by an addition or subtraction symbol is a term. There are 3 terms here. Step 3, first we want to check for 3 terms. Is it a perfect square trinomial? So is x squared is a perfect square? Is 27 a perfect square or no? It is not. So this is going to be no. And the 4th thing we need to do after we eliminate perfect square trinomial is we need to do smiley face. Okay, so what we need factors of the first term, factors of the last term that are going to add to the middle term when we do the smiley face method. Okay, what multiplies to x squared? Well, that's a really nice one. It's a perfect square. It's got to be x times x. So we know for our brackets here, our parentheses, it's going to be x, and x are going to go in the first ones here. Okay, now we have 2 negatives. We have a negative here and a negative here. What's that going to give us? What do the terms have to, where are our signs going to be here and here to make that a negative? Well, to get negative 27, how can we multiply 2 numbers to get a negative? Well, we need a positive and a negative, don't we? The only way to get a negative 27 when you multiply the outside terms here is that you need a positive and a negative. So that means that for this, because we have a negative here and a negative here, basically you only need to look at the last term, I suppose. If the last term is negative, it has to be a positive and a negative number. All right? That's the only way you can multiply like 9 and negative 3 to multiply these 2 outside numbers to get a negative 27. So I guess just focus on the last thing here, okay? Well, not necessarily. Actually, you'll need to, if you have a negative and a positive, that means you need to have 2 negatives then, because it's going to be a positive with 2 negatives multiplied together. We'll cover that more often, but for now, yeah. If you have a negative at the end, it means it has to be a positive and a negative. All right, so now we need factors of negative 27. Well, we have, what multiplies to negative 27? We have negative 1 and 27. We have 1 times negative 27. We have 9 times negative 3 and negative 9 times 3. And I think that is it. Okay, let me make this a little bit bigger. So we need a positive and a negative. It needs to add to negative 6 when we're done with these middle terms, like this smiley face here. So what can we check? Well, let's check here. Let's try, what's the right answer? Okay, let's try negative 3 and positive 9. Let's just see how that works. Okay, we're just guessing and checking. What is negative 3 times x going to be? Well, that's negative 3x. What is x times positive 9 going to be? That's 9x. Well, that's going to add up to positive 6x, right? Is that what we want? Well, we want negative 6x in the middle here when we add these. So it's actually not going to be positive. We need to flip these signs. All we need to do is flip the signs. If we get the right numbers down here, we get the right numbers, all we need to do is change the signs, okay? So we're going to change this to positive 3 and negative 9. Let's see how that works. So that's going to be 3x and negative 9x, and that's going to equal negative 6x. So our answer is, this is going to be done. So our answer is going to be x plus 3 times x minus 9. So this is not your answer right here, this smiley face stuff. Your final answer is whatever you factored to, whatever this final unfoiled thing is going to be. And there we go. All right. Let's make it a little bit more challenging now. It's going to be important to know how to do these ones too. So these ones are a little bit more tricky because now we have an a value in front that is not 1. It's going to make it like we have more options to choose from. For example, we have this 4x squared. Well, that could be 2x times 2x, or it could be 4x times 1, or times 1x, I guess, right? So it's going to be a little bit more challenging, but hopefully not too much more challenging. So let's go ahead and get into this here. All right, step 1 again. We're doing any kind of factoring. What do we look for? We look for a GCF. So is our number that goes into 2, 7, and 3? Well, 2 and 3 are both prime numbers, so that's going to be no. Step 2 is to look for the terms. How many things are separated by addition and subtraction symbols here? And we have, you can see we have 1, 2, 3 terms. So we have 3 terms. The third thing we need to check after we figure out the number of terms is it a perfect square trinomial? Well, the answer is we got 2. 2 is not a perfect square, and neither is 3, so this is going to be no. And then the fourth thing we do after we figure out it's not a perfect square trinomial, then we're going to do a smiley face. Okay? So we need factors of 2y squared. What multiplies to 2y squared? Well, that's got to be 2y times y. That's the only way to multiply. You need a y in both of them, I guess. You can't just put 2 and y squared, okay? So our first answer is going to be, or our first part of our brackets here, our unfoiled factored problem here is going to be 2y and y. Okay? What are the signs? We got 2 positives here. Well, the only way to get a positive 3 and also a positive 7y is if both signs are going to be positive. So that's going to really help us out, make it a lot easier here. All right, then because we have positive 3, we need the factors of positive 3. Well, that's only going to be 1 times 3 in some kind of combination. So now we need to do our smiley face method here. So we need things that, where should I put the 1 and the 3 to add up to 7 in the middle there? Well, if I want to get, so let's try putting 3 right here for now. So that's going to be 3y and 2y when you multiply these. That's going to be 5y. That's not what we want. We want 7y. So we got to be strategic here. So instead of putting the 1 with the, or the 3 with the 1y, we can put the 3 with the 2y, and that should help us get a bigger number in the middle, right? So 1 times y is y. 2y times 3 is 6y. So 1y plus 6y equals 7y. So we did find the right answer, which is great. We have 2y plus 1 times y plus 3. And our final thing we need to do is we're done. Okay, number 4 is a good one to talk about. This is a really important one, actually. So we need to go through our steps again. So first step is G, C, F. Is there a number that goes into 4, 8, and 3? No, there's no numbers that go into 4, 8, and 3, and this one does not have an X, so there's no GCF. Step 2 is what? Check the number of terms. How many terms do we have here? We got 1, 2, 3 terms. After terms, we check, is it a what? Perfect square trinomial. Well, 4x squared is a perfect square, that'd be 2x, but 3 is not a perfect square. That would be like 4 or 9 or 25, like we talked about. So this is not a perfect square trinomial. Step 4, after we eliminate all those different things here, we're going to do the smiley face. Or I think it was it called smiley face? We'll come back to that in a little bit. Anyways, so we need factors of 4x squared. What multiplies to 4x squared? This one's a little tricky, because we also have 4x times x and 2x times 2x. Okay? Now, we need to check the signs. We're going to have either, this one we're not going to plug it in right away. We're going to either have 2x and 2x or 4x and x, right? Okay, so we need now we need to figure out the signs here. We need factors of positive 3 that are going to end up with a negative in the middle here. So if we have a positive for the third term, but we have negative terms in the middle here, it has to be that these are both, we have 2 negative terms for 3. That's the only way we can end up with a, like if we add these together, that's the only way we would end up with a negative, with a negative middle term and also a positive end term, right? So let's go ahead and do this here. So this is going to be two negative numbers being multiplied together here. That's the only way it's going to end up being positive 3, but ending up with middle negative terms. Okay, now we need factors of positive 3 with 2 negatives. So negative 1 times negative 3 are the only factors. So we can just put negative 1 and 3 right here. All right, now we need to guess and check and do smiley face method for the other 2 terms, which is 4x and x and 2x and 2x. Well, let's try 4x and x. So let's think here. We need to end up with 8x. So let's try putting 4x right now. Not 4x right there. Let's try putting 4x right here, and then x right here. Let's see, what do we get? What is negative 4? 1 times 4x is negative 4x. X times negative 3 is negative 3x. We are so close. That's going to add up to negative 7x. We want negative 8x, though. Is there any way, if we switch 4x and x around, would we end up with a negative 8x? Well, 4x times 3 would be negative 12, which is way far away, so we don't want to use that. That's not going to work. So we probably need to use 2x and 2x for this one. So let's go ahead and do that. 2x and 2x. Now let's figure this out. So we got negative 1 times 2x is negative 2x. 2x times negative 3 is negative 6x. That's going to equal, right? We got the right thing. That's going to equal negative 8x. So we're done. So it's 2x minus 1, and it's 2x minus 3. Okay. Perfect square trinomials. This is a very long lesson. Okay. Let's go to this color right here. All right, perfect square trinomials is this form, a squared plus or minus 2ab plus b squared, and it's going to factor to a plus or minus b all squared. The first and last terms must be perfect squares, which are going to be a all squared and b all squared. And the middle terms must be 2 times a times b. Okay. So we'll do this one two ways. We're going to do it the perfect square method and the smiley face method. We'll do the perfect square method first, okay? So again, step 1 is to do what? Look for a GCF. Do we have a GCF here? Well, this is a 1. That's no number that goes in all these. This one doesn't have an m, so this is going to be no. Step 2 is to check the terms. And that's going to be 3, right? Step 3, you would do perfect square trinomial. In this case, we would. Why don't we just do perfect square trinomial first? This one is perfect square trinomial because we have this is m squared, and this is 7 squared. And the middle is going to be 2. Let me just figure this out here. So we're going to have, this is m squared, this is 7 squared, and this is going to be, let's check. So the square root of m squared is m. The square root of 49 is 7. What is m times 7 going to be? That is 7m. And what is 2 times 7m going to be? Well, that is 14m. So we verified that the first term is the perfect square, this last term is the perfect square, and the middle term is double the perfect squares multiplied together, which is going to be 14m. So all we need to do after we do that, the shortcut, instead of doing the factoring, is just to do, the shortcut is, it's going to be, these are both positive. So a 2 positives perfect square trinomial is going to factor to m, the square root of the first one, plus the square root of the second one, all quantity squared, and that's going to be your final answer. So that's a shortcut. If it were like a minus 14m here, it would be m minus 7 all squared. And those patterns are on your factor flowchart, and you can use those on the test or quiz, so just be aware of that. But yeah, so that's all you got to do for this one. But let's also do the smiley face method too, okay? So smiley face method, we have m squared factors of m squared are m times m. Factors of 49, well, these are both positive here. So you have to both be positive. Factors of 49 are 7 times 7 and 1 times 49. So we need to do the smiley face method here. So we have m times m. They're both positive, which is going to be really nice. It needs to add up to 14. Well, I'm not going to use 1 and 49 because that's going to give me 50 when I add those. So I'm going to use 7 and 7 right here. Let's check it. 7 times m is 7m. M times 7 is 7m again, which equals 14m. So you can see it's going to equal m plus 7 times m plus 7. But that reduces to what we did over on the left over here, which is we have 2m minus m plus 7 squared. It's going to 2 plus m plus 7s, which is going to be m plus 7 all squared. And so we got it both ways. So either if you struggle with figuring out the pattern, just go ahead and do it this way too. Do your smiley face method. Either way is totally fine, but the pattern does save you some time and effort, I feel like. All right, we have a lot of examples left to do here, so I would probably give these last ones a try on your own. Pause the video, see how you do, and we'll go through them in a second. All right, welcome back. Let's get into this. So we have 4x squared minus 100. I'm not going to write out all the steps. Well, I'll write out the steps. Why not? We might as well do this the right way, right? So step one is always look for a what? GCF. We have a GCF here. Is there a number that goes into both of these? Yeah, 4. We can pull out a 4. Divide them both by 4. This one doesn't have an x squared, so we can't pull out an x. So we're going to have 4. Divide them both by 4. 4x squared divided by 4 is x squared. 100 divided by 4 is negative 25. Okay, we got GCF. Second step is to what? Terms. Well, the number of terms right here is we have 2. After we check 2 terms, the only other pattern we can check for with 2 terms is difference of squares. In this case, we have 2 perfect squares. We have x squared. We have x squared minus 5 squared, which is going to be, yes, this is a difference of squares. So we're going to have, and you kind of don't worry about the 4 for now. The 4 is kind of factored out. We're just worried about this middle term right here. Middle terms, I guess. So this is going to factor too. The shortcut is, if we have difference of squares, it's going to be the square root of the first one plus the square root of the second one, which is 5. And square root of the first one minus the square root of the second one, which is negative 5 there. Or minus 5. And there you go. That's factored. All right, number 2. Number 2, again, first thing we always look for. I'll go over here. First thing we always look for is GCF. This is going to be drilled into your head by the end of this lesson, but that's a good thing. Do we have a GCF here? Is there a number or exponent that goes into both of these? Well, the biggest number we can pull out of here is a 3. So it's going to be divided by a 3 at least. Is there a variable we can pull out 2? Smallest exponent between x squared and x is just x, so we can pull out an x as well. So we divide 3x squared divided by 3x. It's going to be just x. The 3's cancel. 2 minus 1 is 1x. Negative 24 divided by 3 is negative 8. And then x divided by x is going to cancel, and we get our answer of this. So GCF was yes. Terms for the inside part of the parentheses is 2. Then we check, is it a difference of squares? And the answer is no, they are not even squares. This is not a square, this is not a square, so this is where we stop. There's our final answer. All right, a few more examples, and some of these are not going to work out nicely, so just be aware of that. All right, we have 5x squared plus 17x plus 14. So first thing is to do what? GCF. Do we have a GCF here? We have 5 and 14 and 17. 5 and 17 are prime numbers, so this is going to be no GCF. 2 is terms, right? We have 3. Step 3 is to, if we have 3 terms, is check if it's a perfect square trinomial. In this case, 5x squared. 5 is not a perfect square, neither is 14, so this one's going to be no. Then step 4, after the non-perfect square trinomial, is smiley face. So we need factors of 5x squared. Well, that's going to be 5x times x. It has to be. That's the only things that work. These are both positive signs, which means they're both the middle terms are both going to be positive. They're going to both multiply to be positive there, which is nice. We already got most of that narrowed down. Now we need factors of positive 14. Well, we got 1 times 14. We got 2 times 7. Is that it? So which number should I use to end up with 17? Well, if I use 14 and 1, even if I put 14 with the x, that's going to be way too big. So it's probably going to be 2 and 7. Where should I put the 2 and the 7 to end up with positive 7? Let's try putting 2 right here and 7 right here. Let's see what that works. We're just guessing and checking. It's going to be 2x and 35x. That's also too big. So we can't do that. So let's instead put 7 right here and put 2 right here. Let's see if that's going to work. 7 times x is 7x. 5x times 2 is 10x, which equals 17x, which is great. So our final answer is going to be 5x plus 7 times x plus 2. And so our final thing is we're done. All right, there, that one's factored. All right, number 4, 4z squared minus 12z plus 9. Okay, so we have, first things first, GCF. We have a GCF here. 4 and 9 are even and odd numbers. They do not have any numbers in common we can pull out. There's no GCF. And no x, this one doesn't have any variables, so that's not going to work. Terms. Terms. How many terms we got here? We have 3. 3 terms. Is it a perfect square trinomial? Well, 4z squared is a perfect square. That's 2z. And 9 is also a perfect square, which is going to be 3. It's the square roots. This one say yes. So we're going to actually do a shortcut here. So the square root of 4z squared is 2z. Square root of 9 is 3. We got to check the middle term too, though. So we're going to do 2 times the 2 square roots. 2z times, times 3, which equals 2 times 6z, which equals 12z. So is that the middle term? Does that work out? It does. This is a shortcut. So we can actually do the shortcut for this is going to be, this is a negative here. So we don't even need it. If you want to do smiley face method, you can, but we're going to stop here and do the shortcut with the perfect square trinomial if we were able to. It's going to be 2z minus 3 all squared. So I'll put in parentheses smiley face if you want to still do that. But this is the final answer, is 2z minus 3 all squared. Okay, trying to save us a little bit of time here. All right, number 5. So, number 5, we have step 1, GCF. I'm going to go kind of quick here. We have no GCF. Step 2, do we have, how many terms? We have 3. Step 3, perfect square trinomial. That's a no. Step 4, this is going to be smiley face. Okay, so if you do this, so the factors of x squared are x times x. A negative and a negative is going to give us, we have to multiply a positive times a negative. Oops. Positive times a negative to end up with a negative 10 at the end. So it means we're going to have something like this. X minus, or plus that is. X plus and x minus. We need factors of negative 10. So that's going to be negative 5 and 2, or 5 and negative 2, or negative 10 and 1, or 10 and negative 1. But for this one, when you plug it all in, all these combinations of these factors are not going to work. So we're going to get, so I'm just going to try, for example, 2 and negative 5. If we do that, we're going to get 2x, and we're going to get negative 5x. Okay? So there's a couple different options here. This is what, we're right here, doesn't work. That could be decimal or imaginary answer. So there's always 2 roots or 2 things that when you factor, but this one you have to use quadratic formula. So not possible to factor nicely. Basically means there's no numbers that are going to come out nicely to hold numbers like that. So you have to use, which we'll talk about later, quadratic formula. Okay, so that's our final answer, is we can't factor it. Sometimes that's an option. Okay, if it doesn't factor, that means that it's either, it doesn't cross the x-axis, or it just is a decimal, kind of result. All right, number 6. Got 3 more to go. Okay, go through this quickly. GCF. Yes. This one does have a GCF, which is 2. Divide them all by 2. We're going to get 2 times b squared plus 6b minus 27. Step 2 is terms, and that is 3. Step 3 is perfect square trinomial. And the answer is no, because 27 is not a perfect square. So step 4 is smiley face. Okay? So we need to do smiley face method, so we're going to do factors of b squared, which is b times b only. We have a positive and a negative, which means these both have to end up being a positive times a negative. And then 27 factors of negative 27 are going to be, I didn't even solve this one, that's weird. Factors of 27 are going to be 9 times negative 3, negative 9 times positive 3, or negative 27 times 1, or 27 times negative 1. So we're going to be figuring this out together. I didn't solve this one out. So we got b, we got a plus and a minus. To end up with 6, we need, let's see here. We're going to do plus 9 minus 3. So if we do that, we're going to get 9b, and we're going to get negative 3b, which equals 6b. So our final answer is going to be 2 times b plus 9 times b minus 3. Does that work? I think it does, yeah. All right, 2 more examples. Home stretch. All right. Step 1, GCF. Yes. Which is 3. So it's going to be 3 times x squared, divide everything by 3, minus 10x plus 25. Step 2, terms. That's also a yes. It's not a yes, sorry, it's 3. The terms are what's inside the parentheses there. We have 3 terms. Step 3, PST. That's also a yes, because we have x squared, square root of x squared is x, square root of 25 is 5, and we have 2 times x times 5. Double the square roots multiplied together is 2 times 5x, which equals 10x. So now we can do a shortcut. We can do 3 times, and the shortcut for this kind of thing is going to be x minus 5 all squared. All right, last example, number 8. Step 1, GCF. This one does not have a GCF. Step 2, terms. This is going to be 3 terms. Step 3, perfect square trinomial. This one's a no, because 51 is not a perfect square. Step 4, smiley face. And for this one, smiley face, we got x squared is going to be x times x. These are going to give us negative times a negative. And the 2 negatives are going to be negative 1 times negative 51. Or negative 3 times negative 17. Those are the factors. But this one's also not going to work. So if we do x minus 3 minus 17, that's going to give us negative 3x and negative 17x, which is not, it's going to equal negative 20x. So that's not going to add up to the middle terms. This one's also not able to factor. Not possible. Need quadratic formula. Okay, this is probably one of the longest lessons I've ever recorded. I appreciate you staying with me and doing your best. We'll figure out, I just wanted to record this all in one lesson, see how we did, but this will be, we'll go over this in a couple days, I believe. This is a hard lesson. Just do your best to follow along. Use your factor flowchart, and you guys will be good to go, okay? Thanks for watching. Have a great day, and we will talk soon.